All right, we're going to be covering one of my favorite aspects of statistics, the normal model. I'm going to go over how drawing a normal model can tell you so much about a data set you might be dealing with, whether it's a sampling distribution or a specific data set that you know has a normal distribution. So I'm going to go over how you can draw a nice basic normal distribution and use that to answer all sorts of questions about your data. Now, the key to drawing a normal distribution is you want to start with a nice flat surface. So I draw a nice straight line here. Next thing, I'm borrowing this from someone, so I can't take credit for this, but I want my curve to look like a nice, smooth plane ride. So what typically starts when you're taking a nice, flight, you start on the ground and you fly upwards, and then, hey, we're flying, and then we're landing, just like so. The more you do it, the better you get. Gotta be honest, it's been a little while, so I apologize if it's not perfect. Next thing I'm going to do is I'm going to cut this in half, just like so. I'm going to cut off my tails right at each end here. And I'm purposely not doing it too neat because you want to be able to do this pretty quickly in the long run. And then I'm going to cut each of these pieces in half right here. Notice I'm going right in half, just like so. So if you're following along, make sure you're doing something similar to me. What you want to remember is this whole density... Bad coloring job, that's all right. This whole density curve right here, this is going to represent all of our data. Maybe it's our data, maybe it's all of our possible means, maybe it's proportions. Whatever our normal distribution is going to be representing, but that's where all this information is going to be lying here. So now, what would be my next step? Here's what I do. I start with my z-scores. Remember, z-score represents how many standard deviations you are from the mean. Now, in a normal distribution, your mean and your median are going to be the same. Just like any symmetrical distribution, your mean and median are going to be the same. Now, if I'm one standard deviation away from my mean, I'm going to have a z-score of positive 1. If I'm also in the other direction here, I could have negative 1 because I could be one standard deviation less, one above. I could also be 2 standard deviations above. I could also be 2 standard deviations less. When I draw my basic one, I only go out 2 standard deviations. You are more than welcome to go out a bit further. That's fine. But I like to do it fairly quickly, so that way I just go out 2. Now, my next step, here's what I do. I account for my empirical rule here. So I know that 68% of my data is going to lie within 1 standard deviation. And that kind of makes sense because you notice that a good chunk of it right here, I'll color it again, using a different color so you can see it. This is where 68% of my data is going to be. Or maybe it's my statistics. Again, it depends on what my distribution is representing here. But you'll notice that so much of it's already colored in here within 1 standard deviation. Now, 95 of it is accounted for within 2 standard deviations, which again makes sense because when I go out 2 standard deviations, I've got almost the whole thing colored in here. Now, typically your empirical rule accounts for 68, 95, and then 99.7 for 3 standard deviations. When I do my rough drawing here, I don't go out the 3 standard deviations. You can if you want, I don't. What I then do is I recognize that, okay, I've accounted for 95% of my data. That means I have 5% of my data left. So I am going to cut that in half and put half of that at each tail, which would be 2.5%, just like so. You might think, wow, this looks pretty detailed. He must be done. Oh no, I still have a ways to go here. So what I'm going to do now is I'm going to look within that 1 standard deviation, 68% of my data. Or again, it depends on what I'm looking at. It could be data. I'm going to say data for the sake of what we're working with. But again, remember, it could mean statistics. You could be looking at sampling distribution. We don't know. So I'm within 1 standard deviation. We've got 68, but if I'm going just with half of this, that means 34% of my data can be accounted for within 1 standard deviation in the positive direction, as well as 1 standard deviation in the negative direction. So now I've accounted for 68% of my data. If I do a quick 95 minus 68, I'll get 27%, which means I still have 27% of my data left. Okay, so let's see. I'm going to account for that 27 right here and right here. If I take that 27 and I cut it in half, I'm going to get 13.5% of my data between -1 and -2 standard deviations, and 13, well, that was an awful 13. I'm going to try that again. 13.5% of my data within 1 and 2 standard deviations, which makes sense because you'll notice that less of it is colored in here when you're going between 1 and 2, then 0 and 1. And I've got that 2.5 I've already accounted for. That 5%, I don't have to account for that anymore. So I'm in pretty good shape. Now you might be thinking, wow, he's got a lot of information here. Is he done? No, I'm not done. I still have a little ways to go here. I'm going to count for my percentiles. I'm going to write percentiles. Now remember, that's all the data that is less than or equal to a specific data value. So this involves looking below each of these. So if I go below 2 standard deviations, you notice I'm only going to be coloring in this. Now I account for 2.5% of my data. So it would be the 2.5 percentile. If I wanted to go up to -1, notice that includes that 2.5 I included before. So all of this is going to be included. That's going to give me 13.5 plus 2.5 is going to give me 16. So I'm looking at the 16th percentile. Right here, right up to my median and my mean right here in the middle, that counts for my 50th percentile. Again, I'm going to color all of this, so I'm accumulating more here. Again, this would include all this. I'm just doing a bad coloring job. This would account for the 84th percentile. Accumulate a bit more. I'm going to accumulate another 13.5%. I'm at the 97.5th percentile, which makes sense because look at all this data. That is less than 2 z-scores away, or 2 standard deviations in the positive direction from the mean. There's so much data that would be beneath that. And I'm going to end it right there because, again, I ain't go out 3 standard deviations. You can if you want for yours, but I'm just going out 2. And then I'm just going to put percentile here too. I like to keep my labels at both ends. So you might be thinking, boy, he must be done. I'm not done yet. I want to include some data here. So what data am I going to be looking at? For this one, I'm going to use IQ. So you notice I'm going to label it right here. I'm going to put IQ. And I know, based on my research, which I am double-checking my cell phone right now, not going to lie, the average IQ is 100. The standard deviation is 15. And it is a normal distribution. You can look it up. So that means if I go up 15, that's going to take me to 115. If I go up another 15, that's going to take me to 130. Now, likewise, if I go backwards, if I subtract 15 from 100, it'll take me to 85. If I subtract another 15, it takes me to 70. So now I have my data, I have my z-scores, I have my percentile. I'm in pretty good shape, and I can say so much about IQs now just based on using my drawing and the empirical rule. What can I tell you? Let's see, I can tell you that 34% of IQs, I'm going to use another color here. I know it's getting a little messy. Let me see if I can try to erase these colors. Hey, what do you know? Yeah, let's do that. That way I can reference these a little bit easier. I can tell you that 34% of IQs lie between 100 and 115. I can tell you that 68% of IQs lie between 85 and 115. I can also tell you that 95% of IQs lie between 70 and 130. I can tell you that if I have an IQ of 130, I'm in the 97.5th percentile. If I have an IQ of 85, I'm in the 16th percentile. I can tell you that if I have an IQ of 100, I'm in the 10th percentile. You can even go a little bit further with this if you want. You could say that 2.5% of IQs are above 130. You could also say that 2.5% of IQs are less than 65, I believe. No, 70. There you go. I could tabulate this a little bit further. Watch this. I'm gonna get crazy here. 47.5% of IQs are between 70 and 100. See how many different directions I can go in here? That is what is so cool about drawing a normal distribution like this. You can do it pretty quickly. Watch this. I'm a pro at this. I can do this really quickly if I want to. Boom, 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 boom. 68. Oop, that's really bad, but that's okay. 68. 95. Got my Z's here. I'm going to go 0, 1, 2, -1, -2. My percentiles, 2.5, 16, 50. And then let's say, it's been a little while, 84, 97.5. Boom. Look at all this information I already have here. Oh, I'm going to put in my 34%. 34%, 13.5. And believe it or not, if you were taking, say you're taking AP Stats, the AP exam, you'd be amazed at how many questions you can answer based on normal distributions just by using this drawing. If you're taking a basic statistics class too, especially if you're doing a chapter on normal distributions, just having this, it's a great frame of reference, believe it or not. Like even if you come across a question like, what's the percentile for a Z-score of -5? You might not be able to give it an exact answer, but you can approximate it and say, all right, well, I'm looking here. I know it's going to be somewhere between 16 and 50. Maybe it's going to be like 37. Maybe it's going to be the 37th percentile. And especially if it's multiple choice, you can really get pretty close to the right answer without even having to pick up a calculator just by doing this drawing. I highly recommend using this if you're taking an AP Stats class or any stats class, because again, it can be so helpful to you and it can save you so much time, believe it or not. It can save you the hassle of having to use a calculator. So hopefully this helps you in your endeavors when it comes to a normal distribution.